Hello Year 12. Today we're going to be looking at dot point 9.2.1.S2. Gather, process and analyse information from secondary sources and use available evidence to develop a model of a feedback mechanism. So first thing we need to do is unpack the dot point. We've got 9.2.1.S2. Remember, you can think of the ones that have an S in them as skill builders, okay? So this is where you need to be exercising your brain and have a go at actually doing things yourself using other resources. So it's gather, process and analyse information. When we analyse, we talk about the relationship between things. That's what we're focusing on, is the relationship between different things. From secondary sources, so you guys need to use other sources, books, websites, anything like that, and pop all the information to be able to develop your own model of a feedback mechanism. And I'm going to give you some examples and then you guys will have a go at doing it on your own. So as we know by now, homeostasis is our body trying to maintain the same state at all times, and it involves being able to detect any changes in the environment and then responding to that change. So actually monitoring the changes and responding to them is called feedback. And our bodies are constantly at all times monitoring our internal environment. Any changes, and it sends the message up to the brain, and the brain decides on a response. So the feedback system has three main parts. There's the receptor, which is the sensor that monitors the internal environment. They're generally some sort of nerves. The control center, so it receives information from our sensory messengers and decides on a response. And then the brain, it's generally the brain, it sends a message to the effector that says, do this to help our body balance out and restores homeostasis. So there's two different types of feedback systems in our bodies, positive feedback and negative feedback. And here's just a bit of a general idea on the monitoring and control for homeostasis. So as you can see, if there's no variable, if the environment stays the same, happy days. However, if there's some sort of imbalance, whether there's too much or not enough of something, that's when we get this feedback mechanism happening. So some sort of stimulus, some sort of change in the internal environment is picked up by a receptor, which is a sensor. Generally, it's some sort of nerve that sends a message through our nerves to our control center, which is our brain. And our brain decides on some sort of response. So it sends a message to the effector saying, hey, this is what you need to do, and we're going to get our body back to normal. And the effector is normally a nerve or a hormone being released into the body. So the first type of feedback that we're going to look at is positive feedback, and it's actually quite rare in our bodies. It doesn't happen on a daily basis. It's only in more extreme circumstances that we get positive feedback, and that occurs when the body actually enforces the response. So it keeps that change going rather than adjusting for it and turning the body back to its stable state. And a good example of that is during labour. So you can see in this diagram, once the body starts going into labour, the head of the fetus pushes against the cervix, okay? And the cervix obviously have lots of nerves, and these nerves send a message to the brain saying, hey, there's pressure on us. The brain then sends a message to the pituitary gland, and it secretes a chemical hormone called oxytocin. Oxytocin is then sent through the blood to the uterus, and oxytocin is a hormone that actually makes the uterus contract and when it contracts, the fetus gets pushed onto the cervix even more, and this cycle keeps happening basically until the baby is born. So more pressure ends up on the cervix because the baby is being pushed further into it. Nerve impulses are sent back to the brain again saying, hey, it's happening and it's getting worse. The brain says, right, we need more oxytocin, sends it down. That makes the fetus push even harder on the cervix, and this is actually keeps going until the baby's born. So the body isn't actually stopping that change, it's telling it to keep going. That's what makes it positive feedback. Negative feedback is much more common in our bodies. It happens on a daily basis, probably hundreds of times. So negative feedback is when the body decides on a type of response that actually reverses the changes to take its body back to what it is normally. So it's a bit like a seesaw, as you can see, that maintains some sort of balance in our body. And an example is things like body temperature, blood glucose levels, all those kind of things. So there's a normal level, the body's happy, no need to worry. If the level gets too high, the body lowers it. If the level gets too low, our body raises it. So this is an example for you guys, and you can see that it's a bit of a double loop, so it kind of looks like a figure 8 going on here. And this is the kind of negative feedback model that we want you to look at as well. So this is an example. You guys are going to do a different one, but this is just an idea on what you need to be thinking about. So this is for glucose in the blood. Obviously, glucose provides our cells with energy, so it's important to have the right amount in our bloodstream all the time. A normal level is around 90 milligrams of glucose per 100 mils of blood. So generally, after we eat, our food contains lots of glucose and our blood glucose level rises. The pancreas detect this change and release insulin. Insulin causes two things to happen. First thing it does is causes the liver to take up glucose, and it converts it to what's called glycogen, which is basically a form of glucose that the liver can store, and it keeps it stored there for when it needs it later on. The other thing that insulin causes the body to do is it makes body cells take up more glucose. So it says, hey, we've got heaps, have some extra. And so the body cells absorb more glucose. Obviously, we don't eat all day every day, so our levels are eventually going to go down. So when blood glucose levels drop too low, the pancreas detect this change again, but this time they release a different hormone called glucagon. And glucagon just acts on the liver, so the hormone message is sent through our blood to the liver, and it tells the liver to break down glycogen into glucose. And once it's broken it back down into glucose, it gets released into the bloodstream, and there's higher levels of glucose, and we're back to normal. Okay, so what you guys are going to have a go at doing is one of these types of negative feedback as a model similar to this. We're going to compare it to a thermostat because that's actually a really good model for our body temperature control. So in science, we basically use models as to show a bit of a visual representation of something that we can't normally see. So obviously we can't normally see these feedback mechanisms. We can't see insulin flowing through our blood. So this is just a bit of a visual guide, and that's what you guys are going to have a go at next lesson. So enjoy.